Hello, everyone. Am I audible?
Audible.
Uh, Audible. Okay, so starting with this session. So today we'll be discussing about the week 5 lectures and doing some of the problems uh, in the course Microprocessors and Microcontrollers. So starting with the summary. So most of the lectures were related to were concerning the 8051, but the first one was regarding the some of the important instructions that were left out in previous lectures. So can we discuss what are these important instructions? Let's say ADC, CMC. I think somewhat we have discussed them at some level. So these are the some of the remaining instructions. ADC is add with carry, CMC is complement, like that, right? So I think we should begin with 8051. So just a minute. Okay, yeah. So starting with 8051. So 8051 is a microcontroller as opposed to 8085, which was a microprocessor. So can anyone tell me what's the basic difference between microprocessor and microcontroller?
Hello. Am I audible, ma'am?
Yeah.
So the basic difference between a processor and controller that a processor doesn't have any memory built inside it. It's a register-based device basically, and in a controller, the registers are there, the memory that is connected with it. It's a compact uh, form of processor. Better form, the timer circuit, everything is there in that controller.
Yeah. So basically, the only difference is having memory and not having memory, right? So
Yeah, ma'am.
any microcontroller would have a memory on the chip. Microprocessor wouldn't have the memory, right? Otherwise, yeah. So the basic components will be RAM, ROM, IO ports, timers, serial interface, right? And about the other, just so 8051 is an 8-bit microcontroller. Why 8-bit? I mean, why do we call it an 8-bit microcontroller, or why do we call my 8085 8-bit microprocessor? Because they have 8-bit ALU, right? Arithmetic logic unit, and thus they can perform 8-bit arithmetic at a given time in one cycle, right? Then 8051 has a 16-bit address line, address bus, and hence it can access how many memory locations. If it has 16-bit address bus, then what number of locations can be accessed by
2
a
to the
chip
power 16,
2 to the power 16, which is equivalent to
4
64
KB.
KB,
Yeah.
right? Yeah. So it has 16-bit address line, and it has a 8-bit data bus. And are, I mean, it's similar to the 8085 only. It is multiplexed with the lower order address bus, which means we have AD0 to AD7, which can act as both data bus and address bus, depending on the situation or depending on what cycle our instruction is on. Uh, then 8051 operates on clock frequency of how many megahertz? What is the clock frequency of 8051? a clock which is connected to these. If you can see, yeah, crystal is connected here, right? 12
12
megahertz.
megahertz.
Yes. So the clock frequency is 12 megahertz, right? Next, yeah, so the clock frequency is 12 megahertz and it comes from a crystal oscillator which is connected to Xtal 1 and Xtal 2. Then, okay, and we can calculate a machine cycle from this clock frequency. How? If clock frequency is 12 megahertz, what will be the timing of one machine cycle?
1 by F.
Okay, 1 by, right?
F. Yeah.
So actually it is divided by 12 first, right? My bad. Uh, so it will be about 1 microseconds, right? If you divide it by 12, out 1 microseconds. I don't remember the exact number. Okay. Then, okay, these are the basics. Hmm. Other features are 6 interrupt sources, 2 external, 3 internal, and a reset. Then we have kilobytes of external ROM, and it can be just a minute. Hmm. So 6 kbs of external ROM, 6 kbs of internal external RAM, and okay, I think this should be a question for you guys. So, what is the size of external ROM and RAM? I think I just told you. Internal ROM and RAM. First of all, what is the size of internal ROM?
4 kilobytes
4K
internal
byte.
RAM. K bytes
4
internal RAM.
bytes,
Yeah.
right? And RAM,
128
128
bytes.
bytes.
128 bytes. And external ROM and RAM are both. At max, they can be 64K bytes, right?
Yeah.
Okay. Then what else? And code memory is selectable by this enable EA bar signal, which can be internal or external. And we may have external memory as data or code, depending on what the signal is, right? I think this was discussed in class really nicely. Then we have bidirectional I/O ports. Can you tell me which of the ports are out of the 4 ports? First of all, do we understand what are ports? Register banks ports. No, we are talking about ports. Yeah. So what are ports? P0, P1, P2, P3. These are I/O ports. And why are they called bidirectional?
IO ports means through which the controller can take exchange data.
Exchange.
Means
Yeah, okay.
it may receive or may transfer.
I'm not able to hear you actually. Can you write it in the chat? Or anyone else can. Okay. Actually, the volume is very low. Her voice. Hmm. Okay. Hmm.
Ma'am, may I audible now properly?
Yeah, you're audible, but the voice is very low.
Okay, now
Yeah,
is it? Uh,
better. Yeah.
so the processor can actually, the controller can actually exchange data. Means it may take the data or by those ports using those ports, or it may send the data.
Basically, they can act as both input pins
Put
or
and
output
output
pins,
pins. Yeah,
right?
yeah, yeah.
So that is why they're called bidirectional I/O ports.
Bidirectional.
So as we know, we have four ports: P0, P1, P2, and P3. And as it can be seen from the spin diagram, uh, from 1 to pins 8, this is port 1, which is just, I mean, doesn't have anything else to do. Then we have port 0, which acts as address data multiplexed bus. Then we have port 2, which can act as higher order address bus. This is lower order address. This is higher order address. This is lower order address or give this, right? Then we have this port 3, which can act as serial port. I mean, it has multiple functions, right? Uh, Read external, transfer external, interrupts, timers, read, write, and everything, right? So we have four ports, out of which three of these have multiple functions also, right? Okay. Yes. So next we have a hardware structure of IO pins. This was also discussed in class. Does anyone want me to repeat it? I think it was discussed early. Basically, how to write in an output pin, or how to read write to an output pin, read write an input pin, how to turn off the FET that we have it in had in the diagram, so that we can read in when the I mean, we had this kind of structure, right? This if this flip flop had this connected to port, and this was Q output, this went to an FET, right? And to this is Q bar. To turn it off so as to read from this pin, we had to turn this FET off, so that this whatever is the result here can go back to the port and not uh, uh, what do you say? I mean, if this FET is not turned off, then this result won't go back to this pin. It will go to this port and this FET, and we won't be able to read it, right? So that was the basic idea, the hardware structure. Then we had machine cycles. Machine cycles were I mean, first that reading opcode cycle was same as 8085, as we had learned. Then similar to that only, I think it was easily if you understand the machine cycles of 8085, it was easy to understand that also, right? Um, then we had these important pins. PSEN. What is the okay? So the pin numbers are also given. What is the purpose of PSEN? I have already told you, but can someone decide? What is PSEN used for?
Hello, am I audible, ma'am?
Yes, just a bit louder.
Okay. PSEN is Program Store Enable Pin. It read the signal for external program memory. It's active, no signal.
Yes. So basically, it allows us to access the 64 KB memory, right?
Yeah.
Am I right?
Yes, ma'am.
So you can access and the advantage of having this PSEN is, as we know, the address bus of 8051 is how many bits long? 16 bits. So we can access memory at max. The allowable memory that location that can be accessed should be 64 KB. But we also know that we have external RAM and ROM both of maximum capacity of 64 KBs, right? So with this PSEN signal, we can access 64 KBs of ROM as well as 64 KBs of RAM external. So that's the advantage of having PSEN. Not just single 64 KB of whatever memory, but more than that. Okay,
Yeah, ma'am.
all right. And ALE signal, easy. Just like 8085, it allows us to allows the MUSI to change the or to dictate if address is going to be on the AD0 lines or the data, lower order address or data. Yes. Right? Any confusion for ALE? I think not. All right. And what is the function of EA? EA bar signal.
Hello.
Mm-hmm.
It's external access enable pin, uh,
Mm-hmm.
which is which accesses the external program memory locations from 0 to 4K.
Yes, or the other way to say is it can be used to say used to choose whether the internal ROM of 8051 is going to be used or not.
Yeah, that's also
Right?
correct.
Yeah.
Yeah,
So if EA bar is low, which
means
means
it, this
internal
signal means this signal, if it is low, then it accesses the external memory. If it is high,
yes,
then it
yes,
accesses internal memory.
yes. So if it is low, it's going to discard the internal ROM and going to access. It's going to access the external ROM, right? Then RxD
It's
external
means
read and write. I mean, yeah, read and transfer.
serial IO, serial IO on port 3.
Okay. Uh, Xtal1, Xtal2 we have discussed. Reset will do what? Just reset the it's at 5 right? And upon reset, what are the values of all the main registers and okay. I think reset, everyone knows everything goes to zero, program counter goes to zero. What is different is value of stack pointer, right? So where does stack pointer point to after reset? So there's a particular location that stack pointer has to point to.
Zero zero
Even
zero
on
seven.
restart, yeah. So that yes, 07. So that uh, if whatever the instruction, the starting instruction, if it is to stack some push in some data, stack pointer has to be at some known location, right? So it will after reset, stack pointer will point to 07H, and where will be the stack pointer point to after first push?
Sorry, ma'am. Please repeat.
Let's say the MUSI was reset, right? You pressed reset pin, pressed you reset the MUSI, and there was a stack instruction, a push instruction. Then I'm saying after that push instruction, where would the stack pointer point to?
06.
When push instruction, does it increment the stack pointer or decrement?
Decrement the stack
Decrement,
pointer.
decrement. So 06, 0006.
On push instruction.
Yeah, ma'am.
Yes, push instruction it will decrement the stack pointer.
Yeah, ma'am. There
Really?
is a confusion. It will decrement the stack pointer by 1 or 2. I have a confusion there. In this case of MUSI.
I yeah, please. Someone was saying something. There's a bit. I mean, if you push, there's an instruction push, right? So you push some content of register to a location where stack pointer is pointing. I'm asking where will the stack pointer point to after that push instruction? I don't think it will be
0006 memory location. 0006.
really.
Push operation is done using register pair now, ma'am. So the address will be decremented by 2, and the stack pointer will be pointing by decrementing by 2 address locations.
I'm not
No,
getting it.
that's for processor. It's okay, but is it applicable for controller also? I have a confusion there.
It is applicable to controller also. What am I missing? Just a minute. Oh, yes, sorry. Yeah. Yeah, it will decrement. I don't know why I was confused. Yes, it will decrement the stack pointer. I guess I wanted to say something and I ended up saying something else. Yeah, so it will decrement the stack pointer. And what will be the value of stack pointer after the push operation?
Ma'am, is it 0006 or 0005? Means here also the stack pointer is decremented by 2 or 1.
Uh, yeah, I am confused about that. Okay. First of all, it's not 0006. That needs to be clear, right? It is 07. We have stack pointer on the chip, which means the
No,
address is
ma'am. After push,
07H.
after
Mm-hmm.
push, it is
Mm-hmm.
decremented by 1. So that time,
Yes. Just let me check. Just wait a bit. I am having doubts. Yeah, that's what the problem is. You guys are still thinking in terms of 8085, and that's why I got confused also. So, first of all, what is the address of stack pointer after reset? Is it 07 or 0007? That needs to be clear first of all.
0007. 0007, ma'am.
It is not, it is 07. Now think in terms, I mean, you know what is size of internal RAM, right?
Yeah.
What is it? Mm,
It is 128 bytes.
Yes, so it cannot have 0007, right?
Yeah, zero
It
seven.
must be 07.
Mm.
See, I know in one course doing two processes or microprocessor and microcontroller is going to confuse you, but you need to get this clear that the stack pointer's address is 07 and not 0007. Okay, I think I should have added a memory diagram, but I don't even have it in my notes right now. Should I add it right now? Or do you understand why it shouldn't be 0007? In 8085, the stack pointer was 16-bit wide, right? But in 8051, stack pointer is only 8-bit wide because it doesn't need to be 16-bit wide. The memory is on the chip and individual memories are, uh, what do you say, don't require 16-bit addresses for the internal memory. Only the external memory is 64 kbs, right? It requires 16-bit address for the external memory, not the internal memory.
Yes.
Getting?
Yeah, it is.
Right? So, yeah, that's the confusion there. Now, does anyone have doubt regarding this?
Yes, ma'am. So while the push instruction is executed, that time what
I'm
happens?
coming on that. So, see, stack pointer will point to 07H after reset, right? So, it is 8-bit wide. Whatever you push is going to push how many bits? 8 bits,
Yes, 8 bit.
right? One
Yeah,
push,
06,
right?
8 bit. Yeah,
So what will be the location now after the push?
06H.
06H, right? Is it clear to everyone? I mean, I said it in starting that the basic difference is memory, but it's not I mean, it's not just that in words. Memory, the basic difference in memory creates whole lot of differences, like you see here in terms of stack pointer. Stack pointer is only 8-bit here. Okay, if since we're on that, how many 16-bit registers does 8051 have?
Program counter.
Program counter 1, and
PSW.
I am not able to get you.
DPTR. Data pointer.
Can you please write? You're not audible. And please, others also, please participate. These are the minute details that I think you're seeing how confusing they can be.
So, ma'am, stack pointer will decrement,
Yeah, it will decrement on push as usual as it decremented in 8085. But the question was for what will be the how many decrements will it I mean,
but
by
in the sir
what
given PPT, push instruction will increment the stack pointer is written.
Yeah, there was some confusion there. That is why I was getting confused also. But I think there was some uh, mistake there. You can check it later also. Yes. So there was that confusion there, but it will decrement. Okay. You can check it, and if there's still confusion, you can post it on the forum, right? We'll check it there. So it will decrement. And the next question was how many 16-bit registers are there in 8051? Someone has given the answer. Oh, yeah, so Priyanka has written PC, PSW, and DPTR. Anyone else? So stack pointer, is not 16-bit. What about PSW? In 8085, we have PSW combined, the whole thing with the flag and accumulator, right? So that is why it was 16-bit. And in 8051, PSW is also 8-bit. It doesn't combine with accumulator. The whole this 8-bit flag register is called PSW. It is 8-bit wide. So again, returning to my previous question, how many 16-bit registers are there in 8051? Two.
Then only,
Mm-hmm.
DPTR and program counter.
Yeah, two, right? So we have only two 16-bit registers in 8051 and stack pointer and PSW as opposed to 8085 are not 16-bit here, they are 8-bit wide only. Okay.
Yeah.
Right then. Uh, hmm, uh, okay. Address multiplexing for external memory.
Related to
Uh,
stack, I have one doubt.
uh-huh. Okay. Yeah,
Uh,
please.
so, so the stack pointer being 16-bit in 1885
Okay.
provided us the option of having the depth of the stack, right, to be more. So I can initialize the stack point to FFFF or 0000, and then
Mm-hmm.
from that point I can use uh, the stack. Whereas if the stack
Mm-hmm.
pointer is say 8-bit, the depth of
Mm-hmm.
the stack itself is limited to 256 bytes. So
Mm-hmm.
does it imply that in microcontroller we don't use stack much? Or
No, we use tag. Actually, I think it's. I'm not able to recall if we can use the other memory locations as stack also. I think the answer of this lies there, and I'm not able to recall it. I guess I'll have the answer next week. There's a limited stack locations, right?
yes,
In 8051 as opposed to 8085. I don't have the answer right now.
okay.
Right. So there's this line from my previous PPT. Please ignore this. Okay, so address multiplexing for external memory and external data memory were also discussed with the timing diagrams. So discuss these. Then we have overlapping of external code and data spaces. Yeah, okay. So overlapping of external code means ROM and data means RAM. These spaces allow the RAM to be written as data memory and read the data memory as well as the code memory, right? So this allows the program or the code to be downloaded from outside the RAM as data. I mean, you can fetch the copy the program to the RAM memory locations as data and execute the data as your program. So program, right? So you, I mean, this is the advantage of 8051. Then or Musi and that sort. Then we have on-chip memory. Okay, so on-chip memory is divided into three or I guess four parts. I don't remember. I've written three here. So general purpose registers, which are register banks, which we okay. So how many register banks are there?
4.
Four register banks, right? So we have four total register banks, and why do we have four register banks? I mean, why have we divided this space into register banks? Why can't we just use them as direct memory locations, like other locations? It's a general question. I don't know. Just- Okay, so so there are four register banks, right? And each bank has how many registers?
8.
Eight registers, which gives us total of how many registers?
32.
Four into eight, 32. Now the question is, why do we divide these 32 registers into four banks with the same names? Like first bank will have, oops, first bank will have R0 to R7, second will have R0 to R7, third, fourth. Why do you think the designer would want the general purpose registers to be divided in such a way? I mean, there's nothing technical, much technical involved here, just in terms of optimizing locations or anything. Can you think of any reason? Mm. So, if you think as how we did, how we used the registers in 8085, you might get the answer. So, to address or to use a register or register's contents, what do we had to do? What did we have to do? Let's say you want to move contents of register B to A in 8085. We'll just write move A comma B.
No, first we have to select that register bank, then only we may transfer the data.
Yeah, but the main instruction would be that, right?
Yeah.
I mean, for one register, you have a name B. For other registers also, you had names B, C, D, E. These were the registers, right? You had names for all of the registers. And to access each of those registers, you had different kind of instruction. Different kind as in you had to put the name of that register in the instruction,
Yeah.
right?
Yeah.
So just think a little beyond. If you have 32 registers and you want to access, say, multiple of them or whatever, you'll have to have how many instructions? Different sets of instruction. The instruction will be same. Move A comma this first register R0 of port 1, R1 of port 1, like this. But how many instructions would you need?
32.
Not able to hear you.
32.
32, right?
Yeah.
Is it
Yeah.
feasible? I mean, you don't have to
Not
access all
practically.
the 32 registers at a time, right?
Not practically. Yeah.
Any case, you'll use two registers, accumulator or register, or like that only, right? So, does it make sense to have 32 different instructions, 32 different names, so that you see, understands which location are we talking about? No, right? So, that is why the register banks were created and all the registers in the register banks were named similarly, R0 to R7, so that you can select a register bank out of these four. And then once you have selected, you can choose which register bank you want to work on. And then once you've chosen the register bank, you can choose the registers R0 to R7 of that bank. Let's say you don't want to say disturb the registers of first register bank. You can leave it, change the port, use the other registers of the other port. Make sense? Instead of having obviously 32 different instructions. It works and it works efficiently. So, I don't know, kind of genius, right? Any doubt on this?
So this means we can access each and every memory location individually, directly.
I'm not able to hear. Can you speak a little louder?
So that we can access each and every memory location individually.
Each and every, yeah, register.
Register.
All the registers have some address, right?
Yeah.
So just like in 8085, if you had names for 32 of these registers,
Not
you'd
40.
have, let's say, A, B, C. Even alphabets are not 32.
Not 32.
Alphabets are less than 32.
Yes, yes. It
Let's
will
say
repeat
you after Z you start naming them as A B.
like
Even
okay.
after that, you'll have 32 different instructions for each of the bank registers, right?
Yes.
So to prevent that, what the designers thought was to you are given the option to select the port, right? Now, if you have selected, you select the port first and foremost. After you have selected the port, you can choose which register you want to work on or what operations are to be done on which register, right? So after selecting the port, how many number of instructions do you require to work with any of the registers? From ours, even once the port is fixed, you are going to work with R0 to R7 of that port only, right? So you can have instruction as I don't know, I don't have an example. Let's say you want to access this R1 of port 1 and you had selected port 1 only. And if you want to work on R1, you just need to write instruction move blah blah blah, comma R1, right?
Yes.
Musi will automatically understand which R1 are you talking about because you've already selected the port 1. Now, let's say you had selected port 2 instead of port 1, you had selected port 2. You can use the similar instruction, but that instruction will now be implemented with R1 of port register bank, right?
Yes.
Right. That's what I'm trying to say. That the instruction will remain the same. Only the change of port. You have to select the register bank uh, before accessing this register. Now, does it make sense? I mean, for 8 registers, you'll have 8 instructions only. But depending on what port you select, you can have 32 different registers to work with those 8 instructions.
Yes, ma'am.
Obviously, you'll have to select the register bank first, but it reduces the instruction load, right?
Yes, ma'am.
Is it making sense now?
Yeah.
Okay. I hope it's clear to everyone else. Then we have bit addressable memory. Uh, so there's this part of internal RAM which is bit addressable, and this was also discussed by Sir, I guess, right? Uh, Yep. So you can address these memory locations by their bits. I mean, if you want to change the normally the location will have how many bits? 8, right? So you can access individual bits here and you can change them. I mean, change or copy or whatever operations you do with the whole set of registers, you can do it on individual bits in the bit addressable memory locations, right? Then we have SFRs. SFRs are special function registers. I think Sir is going to discuss these more in further classes. What else? So, how many SFRs are there in 8051? Total number of SFRs? 21. Okay. And out of those 21, okay. So, yeah. So, total are 21. Out of those 21, we have uh, some of them are bit addressable. Not all of them are bit addressable, just like the bit addressable memory. So, bit addressable SFRs are your A, P, PSW, P02, P3, then TCON, SCON, IE, interrupt enable, interrupt priority. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 of them are bit addressable. Uh, A, P02, P3, interrupt enable, interrupt priority. Okay, these are bit addressable. Then, oh, I had written. Okay, so CPU registers used in assembler instructions are A, B, PSW, stack pointer, program counter, DPTR. Okay, with these, okay. Um, okay. So there are different kinds of programming instructions, just like 8085. Uh, There are transfer instructions, addressing modes, data processing, program flow instructions. Some of the examples I can give you right now. Okay, okay, so um, okay, they're similar to 8085 only, and I don't think all of them are discussed in the lectures completely. So, were the addressing modes discussed? I'm not sure.
Yes, ma'am, it is discussed, but in next slide, please, ma'am.
Mm-hmm.
It is discussed, but in next few lectures, not
In
in
week 6, right? Not in week
yes,
5.
yes,
That's
yes,
what. Okay, so
Yes.
I won't be discussing addressing modes. Then I think that completes the, yeah, so some discussion left. Yeah, I think we're done. So yeah, one thing, this ESW register, since you all were confused, we can discuss. ESW is 8-bit here, 8-bit register in 8051 as opposed to 16-bit in 8085, and the structure is given as just the flag register, right? There's no accumulator combined with it. So first one is carry, auxiliary carry. This is programmable flag. Uh, this
RS1,
is RS1,
RS1, this is RS0.
RS1, RS0. Uh, then we
Overflow
have
flag.
overflow.
Yeah.
Then we have don't care and parrot,
Parity.
right? So I think you understand what are these. Carry, auxiliary carry. Parity is also known. Overflow is when you have overflow from the arithmetic operations, right? This is programmable flag. We didn't have this in 8085. This is programmable. No, RS1 and RS0. What are these?
By using these two bits, we can select the corresponding register bank.
Yes, these are, wait, uh, used to select
Register
register
bank.
banks, right?
Yes.
So depending on values of RS1 and RS0, we can have banks, simple digital logic. We can have 4 values since there are 2 bits. 4 values, 4 banks, sufficient. So 00 is 0, 1, 2, 3, right? Easy.
Yes, ma'am.
That is PSW. Then,
Ma'am, what
yeah,
is the
the
what
instruction
is the
cycle is. Mhm.
ma'am? Am I audible?
Yeah, yeah, yeah.
What is the function of that F0? F0 flag.
F0 is a programmable flag. It is uh, it's a flag that can be programmed to keep track. What is the function of flags? To keep track of operations, what's going on, right? So if there's an operation which the programmer or the main program requires to keep you track of, then this F0, this byte can be programmed to keep track of that operation. I don't think I have an example of this, but you can write it out. I'll get an example next time.
Sure, ma'am.
Okay. Just like carry, auxiliary carry, you require them overflow. It's like that. You can program this bit to keep track of some of the operations that might be undergoing. Okay. Then, other than this, yeah, the basic thing, cycles the same. Instruction cycle involves fetching, decoding, execution. What else? Machine cycle, you know what it is, right? One complete thing, one complete operation sums up to a machine cycle. Then what else? Clock cycle is just that one clock pulse. Yeah, I think that sums it up. Okay. Moving on to the practice problems. Can you see my screen?
Yes.
Okay. So questions are easy because it's the introduction only. So yeah, number of pens present on 8051 is
40.
40. Option C.
okay. Microcontroller should at least contain which of the following set of components?
Option C.
Sure.
C.
Yeah,
C
someone
option.
raised the hand. C is correct. Someone raised the hand. Do you have a question? No? Okay. So microcontroller should have CPU, RAM, ROM, I/O devices, serial parallel ports, and timers. Right? Mm. Okay. Which of the following is true in context of 8051? IO port 0 is used as 8-bit read-write general purpose. IO port 1 is used as address bus for external memory. Uh, port 2 is used for internal timers, external interrupts, or none of the above.
A. Option A.
What is port 1 used for?
Ma'am, port 1 is used for only 8-bit read write.
I mean, it doesn't have any alternate function.
No, only for that purpose.
Yes. And port 2?
Uh, Port 2 is 8-bit read write and higher byte of address bus for external memory.
Yes.
Connected
So
with that.
port 0 is used for 8-bit read write and input output operations. Clear?
Yes.
Just a minute. Port 0 is for 80. Yeah, that's what I thought. I should have had 15. Huh. So it's multiplexed as address data lines also. Okay. So I guess this option is missing the multiplexing of, just to be clear of the function, address and data buses. Right?
Yes.
Okay. Next is what is the time taken by one machine cycle if crystal frequency is 20 megahertz? Can you do a bit of calculations? Or first of all, if this is the crystal frequency, what will be the internal clock frequency? Or can it be 10? I mean, if the crystal, you get the clock frequency, internal clock frequency by dividing the crystal frequency by 12, right? Which will give us 20 by 12,
Option B, ma'am.
which will be, I don't know, it's going to be
Option
something.
B.
Then, yeah, just
Point. Yeah.
which will give us one machine cycle equal to 1 by internal clock frequency. So this is what music does, right? Whatever oscillator is or crystal is connected to it, it will divide it by 12 to give uh, internal clock frequency, and from that internal clock frequency, you get the machine cycle. Okay, so this will be about what is it? 12 by 20, which will give us 0.6 microseconds. You can calculate it. Option B is correct. Okay. Next is in 8051, which bit level operation is possible? Which are the possible bit operations are there in 8051? Can you complement a bit?
Yes.
You have the whole bit addressable memory and some of the bit addressable SFRs also. We have one answer. Can you complement the bits?
Yes, ma'am. We
You
can.
can. Can you reset? Yes.
Yeah. And also reset.
You can also reset. So, which gives us
Option
the
D is the
answer
answer.
D,
Option D.
right? So, all of these are possible bit operations. Then, in 8051, the contents of SP register after reset is, I think we have discussed this more than what was required. But yeah,
07H.
07H, right?
Option D.
So, how many 16-bit registers are there?
2. PC and DPTR. B option.
B. We have PC and DPTR. Okay. Okay. So, which of the following ports are multifunctional in 80? I think the question must be which of the following ports are not multifunctional. Because you can't have single
Yes,
answer
ma'am.
here,
Only,
right?
yeah,
Yeah.
one port is not multifunctional. That is port 1.
Yeah. Here to everyone. Okay. So port 1 is not multifunctional. All of the ports are different or multiple functions that can be done through them. Port 1 doesn't have anything other than 8-bit read write. Okay, which brings us to next. The alternate function of port pin 3.4 is, I think you need to remember the diagram for this.
Timer 0, ma'am.
Time is
Timer
0,
0. Yeah. Very
right?
good.
Hmm. If you don't know, you don't know. But yeah, time is 0 for, I mean, at least you should remember what are the different these. If you remember it by port wise, then it's easier to remember because it's 40 pins. You can't just remember them in one go. So yeah, if you know what port 3 is, what are the 8 different locations or different pins on that port, then you can remember, right? Okay. So what is the size of internal room?
128 bytes. Option B.
Internal room, not RAM.
Oh, sorry. 4 kilobytes. 4
4
kilobytes.
kilobytes, right?
D. Yeah.
Please pay
D.
attention because I know it can be. C is not correct answer because it's, I
No,
don't
ma'am.
know,
D.
yeah,
D.
maybe it's
It is
confusing.
D.
It's bits. It should be bytes, right? Yeah. Okay. Apologies for typo. So how many special function registers are there?
21.
21. And how many of them are bit addressable?
11.
Yeah. Okay. I don't think there's any need to write. So 21 SFRs, out of them, 11 are bit addressable. Then we have, which of the following flag is not present in PSW?
Option D.
Option D. And what is GFO exactly? It's a general purpose flag and it's not a part of PSW. Okay. Yeah. Okay. I don't think this. I mean, if you remember the addresses, then sure, and you should remember them because someone might ask you in Viva or something. But yeah, does anyone remember the addresses?
I think option A, ma'am.
Oh, you do.
Because
Yes, option A is correct.
I can
Yeah.
remember TCON and ISCON only. That's why I'm telling.
Okay. Okay, so it's good if you remember, but yeah, option A is correct. TCON has 88H, SCON has 98, SBUF has 99, PCON 87, and PSW T0. Okay, yeah, this one. So, which of the following is true if contents of PSW is 16H? I think I just discussed PSW. So, how are registers
Ma'am,
selected? Which bits are used to select the register bank?
bit 4 and bit 3.
Before and D3, right? So,
They are 1
if
and
the
0.
content of PSW is 16H, then what will be which banks? What is value of fourth bit?
Program uses register from bank 2, I think, because D4 is 1 and D3 is 0.
Bit 3, bit 4 is,
Bit 4 is 1,
and bit 3 is,
0.
bit 3 is 0. So, which bank will be selected?
Bank 2.
Bank 2 will be selected. Is it clear?
Yes, ma'am. Option C.
To, is it clear to everyone? I assume that's a yes. Okay, so C is the correct answer. And then, uh, yes. So when push instruction is executed, what happens to SP?
SP is decremented by 1.
We're still confused on the. I mean, I don't know. Yes, it will be incremented by 1, but I'm still stuck at incrementation.
Ma'am, stack always goes in upward direction, na? So how it will be incremented? It will be decremented now in case of push.
Yes. I don't know from where it's coming. Yeah, so it will be decremented by 1, which
Yeah,
gives us correct answer C. Or maybe I'm confused.
yeah, because
Yes, it
stack.
should be decremented by 1.
Yeah,
Okay, yeah. Correct, which, yes, Sharda. was that no for this question? Yeah, that's what I'm thinking. I don't know why I'm stuck with different. I guess I'll check it also. There's something that I'm not able to recall. It should be incremented. Do you know the reason? Will help me. Okay, I think I had some addressing mode problems, but since addressing modes are not discussed, we can't do them. Okay, just a little question. I'm done with the today's questions, and it's 8:22, so we're left with some time. So which register is used, which is the only register that can be used to transfer data with the external RAM and ROM using MOVX or MOVC instructions. Just this one register, no other register can be used. Can you name it?
Register A.
Yes, accumulator. So accumulator is the only register that can be used to transfer data with the external memory. And yep. Another question. What happens when, I mean, this is related to the program counter. Uh, what happens to program counter value when the instruction, I mean, the program counter contains the values of the next instruction, right? But when is the that program counter incremented? The contents of program counter incremented. Does it happen after fetch, after decoding, after execution? Hmm? Contents of program counter are incremented, right? Because the MUSI has to execute the next instruction. I'm asking, and instruction includes fetching, decoding, and execution, all of three.
After fetch, ma'am.
Yes. So just after the instruction is fetched, the opcode is fetched, um, the program counter contents are incremented, right? So that's that. Then we have discussed the general purpose registers. And what is the reset vector address? It's 8051. Once you reset the MUSI, what will be the vector address? Where will the PC point to?
0000.
Not able to get you.
0000H.
00H, right? 0000H. Then we have discussed read write. They are used for external RAM PSN. Yeah, I think I'm done with the questions. and we have discussed the material from the lectures also. So yeah, I think we're done. So finally, thanks for joining and let me know where I can improve. You have my email. You can pose your questions in forum. That's it. And I hope your questions, your queries are being discussed in forum. Some of you have, I checked, you have questions regarding the lecture material, right? Even with the lecture material, you can ask the questions here. Okay. All right. Thanks. Good night.